clearing the malignancy. Mission continued.
Okay, so this whole video is going to be about potassium and some basically benefits about potassium. Okay, so the first one is insulin-mediated glucose uptake. Okay, so low potassium impairs insulin receptor phosphorylation. So that means that the insulin could possibly not be doing what it's supposed to be doing, such as to be shuttling nutrients around into the cell. Also leads to insulin resistance at the cellular level. So this explains that diabetics are deficient in potassium. Now, why they might be deficient in potassium? Magnesium deficiency. Potassium deficiency cannot be fixed without magnesium being present. Maybe pears and apples. Pears and apples have a quercetin in the skin. So what quercetin can do is lower excessive zinc levels, reducing excessive testosterone, because excessive testosterone, as a result of excessive zinc, can lower estrogen, and that will affect the
high testosterone levels are associated with reduced expression of magnesium transporters. Quercetin supplementation may support mineral balance, but can also influence zinc-like quercetin. Excess zinc intake may disrupt cellular mineral homeostasis. Mineral regulation is complex. Hormones,
people are diabetic because maybe they're maybe too much zinc, possibly from oysters. Oysters are known for having extremely high levels of zinc, so maybe oysters are to be avoided. The GLUT4 or GLUT4 is not able to go to the surface of the cell
excessive
membrane.
Glucose in the bloodstream overwhelms the system, but activation of GLUT4 can be boosted by potassium,
into the cells, because if that glucose is left
restoring balance,
in the bloodstream,
one ion at a time.
that glucose could possibly be doing damage, inflammation, possibly even eating cancer cells. So it's important to get that the potassium in, so that the GLUT4 can is able to catch the glucose molecules from the bloodstream and to take those molecules out of the bloodstream.
Glucose has to be pulled into the cells with GLUT4
in the bloodstream, causing damage. Another thing that a potassium is
activate the transport, power up the pump,
storage, or the conversion of a dietary glucose into stored glycogen for later use, for later energy. This is especially important for bodybuilders and people who work out. They need stored glycogen for later. So potassium is needed for that, because so that is basically glucose into glycogen. So as a result of the glycogen synthase being functional, potassium, glucose is stored as glycogen and not left in circulation. Because low potassium means insulin may be present, but glycogen storage is inefficient. Potassium is not just an electrolyte, it's a metabolic gatekeeper. Required for insulin signaling,
is essential for cellular function. Glucose needs GLUT4 to enter cells. GLUT4 transports glucose across the membrane. Hey, here's potassium. Potassium helps regulate insulin and GLUT4 activity. GLUT4 is crucial for glucose uptake. Now you know how it works.
Glucose out of the bloodstream, so that was just a short recap. Okay, now,
glucose is building up in the bloodstream, but without GLUT4, glucose can't enter cells. That's where insulin comes in. Insulin binds to its receptor on the cell surface. This triggers GLUT4 to move to the membrane and let glucose in.
Insulin can't efficiently drive the glucose into cells, or the glucose is on the outside of the cell and not on the inside where it's supposed to be. So glycogen formation is slowed. Therefore, there is no glycogen storage. There is no energy, meaning that there is no energy for later to use. So it's no wonder that people with diabetes always feel tired and low energy because the glucose is not being stored as energy, as glycogen, because of the potassium deficiency. Another major issue with a potassium deficiency is the potential of glycation of proteins. So basically, that is advanced glycation end products could end up going to the point of no return past the Amadori. So the Amadori point is the point where advanced glycation end product it can be reversed, preventing the irreversible damage that would have been the outcome as a result of a potassium deficiency.
High glucose levels lead to glycation when sugar molecules bind to proteins. These reactions form advanced glycation end products, or AGEs. AGEs damage the extracellular matrix, weakening tissue strength. Potassium helps regulate cellular function and supports amino acid stability.
This goes to show that potassium is a critically important anti-cancer nutrient. So after intermittent fasting, the insulin sensitivity is high. It can be very high. But a potassium deficiency combined with that insulin sensitivity after fasting can actually be bad, because when a person refeeds after fasting, especially with a high carb meal or even low carb,
after fasting, your body is primed for fuel.
The initial surge of glucose
Time to eat
cannot be properly handled without the potassium. So that means that after
this balance keeps you
after
energized and
fasting
healthy
for a long time, that could end up causing the glucose to still be floating out in the bloodstream, because the potassium is not there to boost the GLUT4 out to the surface to bring in the glucose out of the bloodstream and into the cells, therefore leading to risk of the extracellular matrix to become
GLUT4
rigid
is a key transporter
because
protein.
of
When blood glucose rises, excess
end
sugar
product
binds to proteins and
created
lipids. These
by,
AGEs damage the extracellular
excessive
matrix,
glucose in the
weakening tissue
bloodstream.
integrity.
Good
Hey,
way
I've got
to
just the thing.
reduce these
With
advanced
potassium,
glycation
glucose
end
is
products,
removed from the
and could
bloodstream
also
safely.
be a good team up or a good combo with potassium is Moringa powder or Moringa leaves. Now what that does is that, okay, so there's quercetin in Moringa, so that reduces excessive zinc that could be damaging the KEAP1 that is holding hostage
to enable
the
phagocytosis, but
NRF2.
KEAP1 binds to NRF2 and blocks its
Moringa
activation. This stops calreculin from being expressed. Predator. Time to be in. Moringa contains compounds that disrupt KEAP1's grip on NRF2. Now, NRF2 can activate calreculin. Phagocytosis begins. Immune clearance is restored.
Reverse advanced glycation end products that could have been caused from a high sugar in the bloodstream if there was a potassium deficiency. So once NRF2 is released from the clutches of KEAP1, NRF2 upregulates the systems that determine whether Amadori adducts stay reversible or get locked into ages, which is not what anyone wants. So, okay, so NRF2 supports GLO1 and GLO2. So basically, GLO2 is the pathway that is responsible for creating or raising a glutathione. So NRF2 helps GLO2, therefore the GLO2 helps the glutathione, because the glutathione is necessary to help reduce advanced glycation end products. The great thing about NRF2 is that it can recover glycated lysine and arginine.
High glucose levels lead to glycation when sugar molecules bind to proteins. These reactions form advanced glycation end products. AGEs attack amino acids in the extracellular matrix. Time to save the amino acids. Amino acids are essential for tissue repair and function.
Time, because if it goes on for too long, which is a potassium deficiency, allowing the glucose to be floating outside of the cell for too long, creating advanced glycation end products, and then attacking the lysine arginine proteins in the extracellular matrix as a result of a prolonged potassium deficiency state that could lead to the point of no return where it is not reversible and where the NRF2 cannot recover the damaged lysine and arginine proteins that were glycated. Or in other words, glycated would mean attacked by high glucose in the bloodstream. So that's it for the video. Like, comment, share, subscribe. Leave your knowledge down below in the comments, and I'll see you in the next video.